Hi guys, welcome back. Today we are going to learn how to express a number as a product of its prime factors. We've got 4 success criteria, and the first one is to express a number as a product of its prime factors. So to be able to express a number as a product of its prime factors, you need to be confident with finding factors, multiples and primes. So if you're not confident with that, have a go at watching this video on factors, multiples and primes. So in an exam, you could get a question such as the following, and it'll say express, and then it'll give a number as a product of its prime factors. So what does this mean? Well, express is another word for write. Product means multiply. Prime numbers are numbers with only 2 factors. And a factor is a number that fits into another number without remainders. So if we want to express 24 as a product of its prime factors, we create a factor tree to find the prime factorisation. So we start with 24, and we think of 2 numbers that will multiply together to make 24. So I've gone with 12 and 2. Now if either of these are prime, we need to circle them. Well, 12's not prime, but 2 is prime. So I circle 2. Then I do 2 more branches coming off 12, and I think of 2 numbers that will times together to make 12. So 6 and 2. 2's a prime number, so I circle it, but 6 isn't a prime number, so I keep going with 6. So I think of 2 numbers that will times together to make 6, which is 3 and 2. And they're both prime numbers, so I circle those. And that's how I know I'm done. So we can write 24 as a product of its prime factors, which is 2 times 2 times 2 times 3, and that will make 24. We can also write this in index notation, which would be 2 to the power of 3 times by 3, because we're timesing 2 by itself 3 times. This time we want to express 30 as a product of its prime factors. So you can start with any factor pair and we should get the same answer every time. So if we start with 30 and 2 numbers that times together to make 30 would be 10 and 3. 3 is prime, so I can circle 3, but 10 is not prime, so I keep going with 10. 2 numbers that times together to make 10 would be 5 and 2, and both of those numbers are prime. So I can stop there. Now I didn't have to start with 10 and 3. I could have started with any 2 numbers that times together to make 30. So I could have started with 5 and 6 and still get the same answer. 5's prime, so I circle 5, but 6 isn't prime, so I keep going with 6. And 6 is 3 times 2. 3 and 2 are both prime, so I can circle both of those. And that's how I know where to stop. So you can see in both ways, I've got the same numbers. So 30, as a product of its prime factors, is 2 times 3 times 5. It doesn't matter which way you do it. We can also do this using a calculator. So if we want to express 24 as a product of its prime factors, we type in 24 into the calculator, then we press equals, then we press shift, and we press this button here, which is just below the square root button. And the calculator should put it into a product of its prime factors, which is 2 to the power of 3 times 3. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. There's your red answers. And there's your purple answers. And now we've completed success criteria 1. So now we're going to move on to number 2, and this is to find the HCF and LCM using prime factorisation. So HCF stands for highest common factor, and this is the biggest number that is a factor of both numbers. So for example, the highest common factor of 8 and 12 is 4, because 4 is the biggest number that goes into 8 and 12. LCM stands for lowest common multiple, and this is the smallest number that is a multiple of both numbers. So for example, the lowest common multiple of 5 and 6 is 30, because 30 is the smallest multiple of 5 and 6. So we want to find the HCF and LCM of 24 and 30. So first, we find the prime factorisation for each numbers. So we can do 24, 6 and 4. Neither of those are prime, so we circle neither of them. 6 is 3 times 2, and 3 and 2 are both prime. And 4 is 2 times 2, and 2 is prime. Well, 24 is 2 times 2 times 2 times 3. Then we do 30. And 30 can be 5 and 6. 5 is prime. 6 isn't. 6 is 3 times 2, and 3 and 2 are both prime. Well, 30 is 2 times 3 times 5. Now we're going to use these prime factorizations to find the highest common factor and lowest common multiple of 24 and 30. Now for this, we use a Venn diagram, like this. So any number that's in both lists, so for instance 2, can go in the middle. There's also a 3 in both lists, so we can have a 3 in the middle as well. Anything that's left in the list of 24 just goes in the purple circle, so we've got 2 2s. And anything that's left in the 30 list just goes in the 30 circle, so that would be just 5. So the highest common factor are the numbers in the middle times together. So in the overlap section is 2 and 3. So the highest common factor is 2 times 3, which is 6. The lowest common multiple are all the numbers in the Venn diagram multiplied together. So that's 2 times 2 times 2 times 3 times 5, which is 120. So the highest common factor of 24 and 30 is 6, and the lowest common multiple of 24 and 30 is 120. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, we want to find the highest common factor and lowest common multiple of 28 and 60. So we express both numbers as a product of their prime factors. Then we do a Venn diagram. Anything that's common to both goes in the middle. So they've both got a 2. They've both got another 2. And that's it. So anything that's left in the 28 list goes in the red circle. And anything that's left in the 60 list goes in the green circle. Now the highest common factor is everything in the crossover bit. So that's 2 times 2, which is 4. And the lowest common multiple is all the numbers times together. So that's 7 times 2 times 2 times 3 times 5, which is 420. So the highest common factor of 28 and 60 is 4, and the lowest common multiple is 420. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, there's your amber answers, and there's your red answers. And now we've completed success criteria 2. So now we're going to move on to number 3, and this is to apply HCF and LCM to worded problems. So in this question, 2 buses leave the bus station at 9 a.m. One bus takes 48 minutes to return to the bus station, whilst the other takes 36 minutes. At what time will the buses next be at the bus station at the same time? So we express 48 as a product of its prime factors, and we do the same to 36 as well. Then we can put the factors into a Venn diagram. So they've both got a 2 in, they've both got another 2 in them, and they've both got a 3 in them. What's left in the 48 list goes in the purple circle, and what's left in the 36 list goes in the green circle. Now, when talking about time in the future, we need to use the LCM, the lowest common multiple. So we're looking for the lowest common multiple of 48 and 36. So to find the lowest common multiple, we multiply all the numbers in the Venn diagram together, which is 144. Now, because the time is in minutes, that's 144 minutes. So the next time they will be at the station at the same time is 144 minutes later, which is at 11:24 a.m. Here's another example. So a man has 3 planks of wood. One's 12 centimeters, the other's 24 centimeters, and the third is 32 centimeters in length. He needs to cut them into pieces of equal length. So what is the longest length he can cut the wood into without wasting any? So this time we express all 3 numbers as a product of their prime factors, and we do a 3-way Venn diagram, which looks like this. Now any number that's in all 3 lists would go in the center. Then 24 and 32 both have a 2 in them. And 12 and 24 both have a 3 in them. And then there's just 2 2s left in 32. When talking about cutting or making something smaller, we need the highest common factor. So we want the highest common factor of 12, 24, and 32. So that's everything in the center where it overlaps all 3 circles. So the highest common factor is 2 times 2, which is 4. So we must cut the wood into 4 centimeter lengths. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. There's your green answers, and there's your amber answers. And now we've completed success criteria 3. So now we're going to move on to number 4, and this is to apply to recurring decimals. So a terminating decimal is one with a finite number of decimal places. So that means it eventually ends. A recurring decimal is one that doesn't end and has one or a sequence of numbers that repeat itself. So by considering prime factorisation, we need to decide if 15 over 36 is a recurring or a terminating decimal. Well, the first step is ensure that the fraction is in its simplest form. So we need to simplify 15 over 36. So we can divide both numbers by 3, so that would be 5 over 12. Then we write the denominator, that's the number on the bottom, in terms of its prime factors. So 12 is 4 times 3, and 3 is prime. And 4 is 2 times 2, and 2 is prime. Then we use the rule to decide if it's terminating or recurring. Now the rule, if the prime factors are only 2s or 5s, then it's terminating. If there are any other prime numbers, it's a recurring decimal. So because 12 has a prime factor of 3, that means it's going to be recurring. So 15 over 36 would make a recurring decimal. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, and there's your amber answers. And now we've completed success criteria 4. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it and hope you found it useful. Make sure to like and subscribe, and be sure to check out the videos on the rest of the channel. I'll see you next time. See ya.